ஒரு இது ஃபீட்பேக்
Good morning once again. So this particular part, I have made this activity. So whatever the activities we have proposed here, that is going to vary in what money comes. So that was the first topic we have made initially. That we have what we discussed. We have taken part A as average and part B, part A is a multiple test. In part B, we have two divisions of interest. That is part B and part C. Both are coming under
Good morning. Am I audible?
Yes, ma'am, audible, ma'am.
Thank you. Welcome, Surabhi. Uh, and good morning to one and all present here. I'm very happy and privileged to welcome everyone to this international webinar on Raman Spectroscopy and its applications in material science. I welcome our HOD, Dr. L. Jayalakshmi, and I welcome all the members of staff, Department of Chemistry, Save Institute of Technology to this webinar. Now I invite Dr. L. Jayalakshmi, Head Department of Chemistry, to welcome the gathering.
Good morning to all. On behalf
Good morning.
of Department of Chemistry, Sedu Institute of Technology, I welcome you all for this webinar. I am really privileged and immense honor today for getting this opportunity to deliver the welcome address in the special occasion. At this juncture, I welcome our respected founder and chairman of this institution, Mr. S. Muhammad Jalil sir, for giving his helping hands on every right path. I welcome our Chief Executive Officer, Mr. S. M. Sini Mohidi, who always has the vision of bringing the institution to greater heights. Welcome you, sir. Here Marikoyer, who is explained on interest in the development of institutions. I welcome you, sir. I welcome our Director Administration, Ms. S. M. Nilofar Fatima, and the Director R&D, Dr. S. M. Nazia Fatima, who are the navigator of the flagship of knowledge. I welcome you, ma'am. I feel grateful to have the presence of our respected principal, Dr. A. Senthil Kumar, a person who is an inspiration to all. He has given us the path to follow to make our dreams and given the firm foundation for all young minds. I welcome you, sir. I take great honors to welcome our Vice Principal, Dr. G.D. Sivakumar. He is a role model for all the teachers and students for their discipline and incomparable hard work, which he practices incomparable hard work, which he practice in daily life. I pleasure to welcome our Dean Science and Humanity, Dr. D. Leshmana Raj, and our academic coordinator, Dr. Saundra Devi ma'am, who always has the vision of bringing the bright future of our institution. I welcome you, sir and ma'am. It is great honor for me welcome our chief guest, Dr. Surabhi ma'am, postdoctoral researcher, Fujian Catholic University, Taiwan, when it comes to molding and shaping the young minds. I welcome you, ma'am. Thank you. And next, I welcome all deans, HOD, faculty members, friends who work endless to shape young minds and make the good citizen for the society. Last but not least, I would like to welcome the participants from the various institutions for this webinar. I welcome you all. Once again, I welcome one and all. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Now I am very happy to give a brief introduction about my friend, Dr. Surabhi, who is now the postdoctoral researcher in Fujian Catholic University, Taiwan. And I'm very happy in inviting her to this webinar. When I asked her for this webinar, she immediately said yes. She said yes just because of me calling her. And I'm very happy for those words, Surabhi. It's really great, and I'm privileged in welcoming you. And now, though we are friends, I'm welcoming her officially. Dr. Surabhi did her bachelor degree in chemistry with Chem Informatics in Lady Doak College, Madurai in the year 2014. And her MSc degree was in general chemistry at Tyagaraja College, Madurai in the year 2016. She continued with her MPhil in the same college in the year 2017, and she completed in the same year. And she has a great dream towards research. So in order to pursue her dreams, she did her research in chemical engineering in Taipei National University and Technology in Taiwan. And she successfully completed her VIVA with a great ending in the year 2021. And added on her feathers in her cap, she immediately joined as a postdoctoral researcher in Fujian Catholic University, Taiwan. Her research topic focuses on surface enhanced Raman spectroscopy, material synthesis, adsorption reactions, and etc. And she has awarded with many awards, namely a gold medal award in her MSc degree in successfully completing in the year 2017. She got her financial aid scholarship for the international graduate in the year 2021, and she got her research scholarship for international graduate in the year 2020 from CTCI Foundation, Science and Technology, Taiwan. I'm very happy and honored to have such an eminent person amidst us. I welcome you, Dr. Surabhi. Once again, I welcome one and all to this international webinar. Now I hand over the section to Dr. Surabhi.
Thank you, one and all, for being. Am I audible?
Yeah, ma'am.
Yes, sir, audible.
Oh, can I change the? Thank you for the beautiful words that was put forth for me, for describing me. Thank you for inviting Miss Jones. And can I ask, is it echoing? The voice is echoing? Miss Jones, can you just tell me if my voice is echoing or not?
Yes, echoing.
Yes, ma'am. Audible.
But I can hear the echo of my own voice,
Yes, yes, echoing, echoing.
right?
Yes, ma'am, it's echoing.
Oh, please, just give me a moment.
இல்ல அவங்க செல்ல பக்கத்துலயே வச்சிருக்காங்களான்னு பாருங்க.
Actually, ma'am, whether you are logging into system.
Just a minute. Can I switch video from phone to the laptop? All right.
Yes, ma'am.
So today's topic for can anyone tell me how to stop this echoing?
I think the speaker, the main person who is presenting, Babu Vignesh, he has turned on the mic. Someone has turned on the mic. Similarly, they are listening in speaker. That is a echoing problem. So kindly mute.
Hello.
Yeah, now it is okay, ma'am. I think you can go ahead.
All right. Thank you. Inconvenience. So thank you for having me today. And it's my pleasure being a part of this web seminar. And I'm thankful for the HOD and as well as Miss Jones for her invitation as a guest for this web seminar. So today I'm going to talk about the Raman spectroscopy and its application in material sciences. So let me just start off with the introduction to Taiwan. Where is Taiwan and what? In East Asia, it's nearby China, but it is a separate country from China. And it's a small island with a beautiful different culture. And there are so many people who come every year. There are around 8,000 students, Indian students, who come here to study, to pursue their career in various fields. So yes, so the Taiwan culture are a combination of Chinese culture, Han Chinese culture, and European as well as some of Japanese. It's a mixed cultural place. So this previous one, please. Yeah. So here is the picture of the 101, the famous 101 building. It is the 101, which means 101. What do you say? Floors. So, and this is a place, the famous temple place, and here is a memorial of the first king of Taiwan. His memorial, his empire, I think, palace, and it's a beautiful place to live in and to know and to study here. It's a multicultural, accepting people, a place where people, all are accepting. Even the foreigners are very welcomed here, and so it's a good place to just stay. So yeah, next. Variety of transportation, and as you can see, there is a subway, which is a railway, Taiwan Railway, and there is some high-speed rails as well as metros everywhere in the Taiwan, and there are buses as well as taxis as normal as every country has, and there are also public rental bicycles that I can drive. We can just get for so many hours, like as we wish. We can just rent a bicycles and go around places. So here is the last picture, is the picture of a night market. It's a night market. It's a famous night market. There are so many night markets in Taiwan that you can enjoy street food and street cultures. So yes, this is about some of a glimpse of Taiwan's day-to-day life. So the major food variety of Taiwan is more of based on meat and as well as more of rice based. So you can, as you can see, here is a famous meals that has been I have that you can see in the slide, that the hot pot is a famous one of the most popular variety of desserts served in Taiwan. Yeah, next. So let me talk about my university. This is the Fujian Catholic University, and it is the only Catholic university in Taiwanese world. So it's only Catholic, and it was first established by the foreigners in I think people from the Beijing, and they have established their Catholic campus even in Taiwan. And so this is a old, very multicultural university where all the cultural students can come and study together for different degrees. There are many different arts, social, law, and music, and fashion designing, and science and engineering, many departments in our university. Yeah, next. Oh, let me start with the Raman spectroscopy. As you have already been known, you have already studied that Raman spectroscopy is more of a vibrational, and it's about the sound and the vibration, the connectivity. You can just study from that. And there are various advanced fields, applications for Raman spectroscopy, one of which I have been majored, that my PhD was from SCRS, which means Surface Enhanced Raman Spectroscopy. So it was first founded in 1978. Co-workers observed unexpectedly high Raman signals for pyridine absorbed onto a silver nanoparticle. So it was like the silver nanoparticle. Raman, it's a surface enhanced, as the name says, enhanced using the nanoparticles, and hence you can get a beautiful or intense Raman spectroscopy, Raman's entity signals. And from this experiment, the first experiment, the key observations were that the dependence of the enhancement of on the surface preparations was like, the rougher the surface, the more signal were seen. So this was an observation from this experiment. And there was also a property which is directly connected to the SERS, that was the dielectric property of the substrate, such as the metals that are used for these substrates were commonly silver, gold, and copper, while molecular identity was found to be less of a factor on the enhancement. So it was this was the observations that were taken from this experiment. And for surface Raman spectroscopy, one was the chemical enhancement, and second was the electromagnetic theory. So the chemical enhancement theory talks more about the SERS on the roughness and the dielectric property of the substrate, and the enhancement due to the charge in the localized field experienced by the adsorbent of the enhancing substrate surface. Yes, next. So this field what I did in this paper is I took um, I took the motivation from the the motivation for SERS was for me was the SERS offers many advantages, including high sensitivities. It's a sensing method. So SERS sensors are made they are made and they have high sensitivity, selectivity, spec and non-destructive what do you say non-destructive substrate. They are made and it is used for applications for sensors such as identifications of herbicides, pesticides, and heavy metals, as well as many other toxic materials. You can just detect using SERS as a sensor probe. And yes, next. So there are a wide range of SERS active materials, and they are mostly based on the silver and the gold. So disadvantages of using just a metal, some nanoparticles, so such as poor stability, inability to reuse, and a multiple step for preparation process. So hence taking this in account, and we then used the semiconductor materials for as a SERS substrate. As you all know that semiconductor materials have a various are being used in various fields, and its physical and chemical properties such as photoelectric properties as well as narrow band gap and stability is very very efficient for this um, um, uh, sensor applications. But there's a problem with that also. The weak response of Raman spectroscopy, the for the semiconductors, it cannot detect so well. So we have this problem with that also. So there is so what I did in this one of my synthesized a silver-based semiconductor to have the benefit of both the worlds. So I just made a silver-based materials. So this is my PhD motive. We are now talking about one of my papers, which is the silver decorated silver phosphate microcubes with a high SERS performance for detection of heavy metals. So as you all know, mercury and lead are considered among the most toxic contaminants, and there are various methods to detect um, mercury as well as other heavy metals, toxic materials. And one of the beautiful and ERS is you only need small amount of material, and you can detect up to the molecular level of 10 to power of minus 9 or 10, nanomolecular level. You can detect the particles. So among the various techniques, bridging molecule approach forms a superior accuracy and selectivity in SERS based detection for heavy metal ions in solution. So in this paper, I have used the bipyrimidine as the phototypical exobentate ligand that has been widely used and in a crystal engineering for coordination polymers owing to its strong binding ability via the nitrogen, as you all know. So heavy metal binds together with the silver-based silver phosphate, and as well as the heavy metals. So there is a binding, there is a bridge-like mechanism that takes place because of the charge transfer mechanisms, and hence it is very useful for detection of both the heavy metals in a very lower molecular levels. Next. So what in this slide, you can see that I had taken the XRD of the AG phosphate and the UVDRS, and as well as the FESEM. You can see there is a microcubes formations. The goal of this paper was to make a rough surface cubes. So that is why it is more of a rough surface, and the AG is sitting onto the phosphate, phosphate, silver phosphate surface. And we had taken the SEM as well as we have calculated the size distribution curve and EDAX as well as the elemental mapping for this silver phosphate. Here is the XPS plot for each elements, so that we can understand the oxidation states for each elements. And I have plotted for Ag as well as the oxygen as well as the phosphorus. Next. Here is the application part of the SERS. So what I have done here is I have taken the SERS spectra of the bipyrimidine, just bipyrimidine, and then I have added with the mercury, and you can clearly see the intensity rise as well as a peak definitions. There are extra peaks because of the Ag and Hg, and then I have added the lead. So there is a huge, you can see a huge peak difference. Intensity is called what is important in SERS, that the intensity changes, so hence it is very easily detectable for the molecules, and you can easily identify the molecules. And I have also done the XRD in this with different metal addition. I have done the XRD, and each of the peak talks about the presence of the metal in the XRD. Next. Here I have done the experiment for the detection. I have done up to the 10 to power of minus, I think minus, I think minus 9. So, for each for the first green one, if I could say, the first green one was the peak for the Hg, and this next, the red one, was the peak for the for different Pb concentrations. Yes. Next. So I have talked about the mechanism, SERS mechanism. We had to talk about the proposed mechanism of this SERS enhancement. So the Ag silver phosphate as a semiconductor material has a high hole mass and surface energy due to the presence of the phosphate PO bond, allowing the charge transfer process, and the chemical bonding between the molecule and the semiconductor reduces the formation of the transfer complex, and resulting in enhancement of the Raman intensity, and the electron transfer between the Cb as well as the inside the Ag phosphate itself. There is a charge transfer, so there is a double charge transfer, which is very helpful for the SERS mechanism enhancement. Next. So I have taken this spectroscopy, this different concentration. Now I have done it with the real samples. I have tried with the spiking with the tap water as well as in this plot, I have just plotted about the tap water addition, that I have spiked some tap water into it, and I've done for the reproducibility. The peaks are reformed again in a particular area. So here in the first figure, we have talked about the reproducibility, and the next figure talks about the degradation. We have used the same plate, the same substrate material platform, and degraded the material and then used it again. So there is a cycle of four cycles that I've done for this degradation method, and it can be reused as well. Next. So I have in this plot, you can see that you can also check the selectivity of the SERS detection for Hg and Pb over other metals, as well as the stability of the AgPu silver phosphate over during time of I guess it's 30 days. So this is the plot for that, and I have also summarized the parameters in the table below. Next. So the conclusion that I have come to from this experiment was that all silver-based semiconductor material are fabricated using a simple fabrication method, simple precipitation method, and SERS activity was tested, and the characterization studies show that the AG decorated on the uniformly on the framework or on the surface of the substrate will enhance a synergic effect between the chemical as well as the electromagnetic mechanism. And there is a prominent peak observable even at the concentration 10 to power of minus 11 to or 15. And then there is a increase of enhancement factor, and as well as, so the conclusion is that the A substrate for rapid detection of various environmental pollutions. Next. Small publication list, just a publication list. I have I have published 6 papers as a first author, and 2 journey. And now I'm a postdoctoral in different university, and I have just submitted some papers, and I'm just in the process of I have to work on the different fields, so I'm starting to learn more about different fields. So yes, next. So here is my picture of my lab mates from my previous PhD university lab mates, and this is my professor in the jacket. I hope you can see, and this is a team of my my lab, and a life in Taiwan would be a more of a, I can say, more challenging. It seems for the students who want to aspire to become to pursue their PhD or even their higher studies, anything. In a foreign country, you need to be prepared for everything, and there is a cultural differences that you will face. And I hope all this listening to this web seminar, I would that you have upon challenging. Try to take challenges, and it is scary. It is scary to go to another country and start studying there and knowing the culture and being little afraid of that. But I come from a very normal college. I studied in a Tyagaraja college with Miss Jones, and I did not expect seeing myself being a postdoctoral or a PhD doctoral person in another country. But it is hard, it is difficult to do it, but you can do it. I would just encourage all the students. Today's web seminar was not about teaching, it was more about an experience. I just want to showcase a small glimpse of what the life in a foreign country would be for a student who has just aspiration, just motivation to do something in future. And I hope I could if you have any questions regarding your regarding this how to come to another country, or just not Taiwan, I can guide you for you want to go there. You just have to have a very strong motivation and be prepared for the challenges that you are going to come through. And it was a challenging life for me in PhD. It was pretty challenging because in India we have been taught, we have been spoon-fed, we have been always the teacher will teach you, and you have wonderful teacher faculties who teach you every time, and you take the notes and you write the exams, and that's all. But when you come to foreign country, it's not that. It's more independent. The teachers do not teach you, they just come there and they just do a presentation, PPT, and that's all. So you have to study by yourself, know about yourself, learn about everything. You have to learn by yourself. There is not many helpers to help you out here. So if you wish to do something or pursue a career in foreign country in academia, like in academic careers, please do a big research. Like, be prepared for everything. Don't think that it's a fun going to foreign, but it is not. So yeah. Last slide. Can you just show me the last slide? The last one. So you can now ask me any questions regarding my stay and my life in Taiwan, and you can follow me in the in my social medias, or I'm on just LinkedIn. So you can find me in LinkedIn and in Gmail. You can ask me any questions. Thank you. Anybody? Anybody wants to know about more about my life in Taiwan?
Participants, if you're having any questions, you can ask me. Any queries and any questions?